Welcome back. In this video, we are going to solve problem 13-5 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So statement is a rod made from polyurethane has a stress strain diagram in compression as shown. If the rod is pinned at its end and is 37-inch long, determine its smallest diameter so it does not fail from elastic buckling. So let's start with the solution. So you can see this is the stress strain curve for polyurethane that is in under compression, having this 8 ksi load in elastic region, and against that load the strain is 0.003. So you have to determine the smallest diameter so that it does not buckle. So let's start with the solution. As we know that from Euler's formula, that is P critical is equal to pi square E I divided by LE square, where E is modulus of elasticity, I is the moment of inertia, and L is effective length. So first we'll find this E from this stress strain curve. As we know that stress is equal to E into epsilon, and E is equal to stress over strain for elastic region. So from this diagram you can see that this is 8 ksi load and its strain on that load is 0.03 is in elastic region. So I can write it as 8 multiplied by 10 raised to power 3 divided by 0.003. So we will calculate it. So 8 multiplied by 1000 divided by 0.003 will give you 2.6667 into 10 raised to power 6. Okay, so I can write it as 2.667 into 10 raised to power 6 psi. Now we have E, and we know that moment of inertia for a circular rod is equal to pi by 4 d divided by 2 whole square. This formula is pi by 4 r power 4, where r is equal to d divided by 2. And what is effective length? So as we have been given that rod is pinned at its ends, so effective length is equal to k multiplied by the length, where what is k for both end pin. So you can see from this diagram that pins end, for that we have k is equal to 1. So I can write it as k is equal to 1. So k is equal to 1. So effective length will be equal to 1 multiplied by the total length, which is given as 37. So 1 multiplied by 37. Now we have all these values. So we will just plug it in this formula, that P critical is equal to pi square E multiplied by I divided by LE. Instead of LE I can put it 37 square. Okay. Now we can put the value that P critical is equal to pi square E is 2.667 into 10 raised to power 6, and I is pi by 4 d divided by 2 whole square divided by 37 square. As we know that this P critical is equal to critical or maximum load, maximum axial load on the column just before it begins to buckle. This load must not cause the stress in column to exceed the proportional limit. Therefore, we will take this P critical is equal to maximum load. So P critical is equal to this P critical, as this is stress. So we know that stress is equal to critical stress is equal to critical load divided by area. So from here we will get this P critical is equal to critical stress multiplied by area. So critical stress is 8 within the proportional limit. So I can write it as 8 KSI. So 8 multiplied by 10 raised to power 3, and area for circular shape is pi by 4 d square. Okay, or you can also write it as 8 multiplied by 10 raised to power 3 multiplied by pi d divided by 2 whole square. Okay, now this is equation number 1 and this is equation number 2. So comparing equation 1 and 2, compare 1 and 2, we will get 8 multiplied by 1000 multiplied by pi multiplied by d divided by 2 whole square will be equal to pi square multiplied by 2.667 into 10 raised to power 6 multiplied by pi by 4 into d divided by 2 whole power 4. Okay, one thing I did a mistake is that this is pi by 4 r power 4. So r is d divided by 2. So this is power 4. Okay, divide by 37 square. Okay, now what we will get is that this will be equal to 37 square multiplied by 8 multiplied by 10 raised to power 3 multiplied by pi. This d divided by 2 will cancel with this, and here we will left with square only 2 divide by this pi square multiplied by 2.667 into 10 raised to power 6 multiplied by pi by 4 will be equal to d square over 4. Okay, and this d square will be equal to 4 multiplied by this 4 will also go in numerator. So 4 multiplied by 4 multiplied by 37 square multiplied by 8 into 10 raised to power 3 divide by pi square multiplied by 2.667 into 10 raised to power 6, and this pi will cancel with this pi. Now we will solve it. We will solve this 4 multiplied by 4 multiplied by 37 square multiplied by 8 multiplied by 1000. Okay, 4 multiplied by 4 multiplied by 37 multiplied by 37 multiplied by 8 multiplied by 1000 divide by 3.1417 square multiply by 2.667 multiply by 10 raised to power 3 6 3 4 5 6. So when you solve this, this is d square is equal to 6.656. Okay, so d will be equal to square root 6.656. So taking the square root of answer will give you 2.580 inch. So what we will get is d is equal to 2.580 inch, which is the answer of our this question, that this amount of diameter of polyurethane is required for bearing this 8 KSI critical stress that will not fail from elastic buckling. And that was all about problem 13-5. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.